let's take a look at what a well-structured query will be for you as you work as a data analyst. So here we have the select. Now, select is the almighty of SQL. We are selecting the employee name here with department. We're also doing some aggregation. I'm going to go into why aggregation is really important in a minute, but you need to know that group by is really important anytime that you're aggregating your data. So here we're using some salary as total salary. So if you want to alias your columns in SQL, you can use as. In fact, you don't even have to use as. You could just do total salary, but I recommend that you put as every time. It just makes for more readable code in general. So we're doing aggregation on the employee's name and the department name. So let's go down to where we're pulling this data from, which is in the from clause. So from employees. So from employees is the table. This is the first statement. It's your first table. You typically want to have the biggest table in your from clause. Then you can join on that data, but just know your from is what you're trying to basically pull from. The join, very simple. Anything after, we hear your key is department ID. This is your primary key. This is your join key. Now there can be issues with joins, so make sure you know there may be an issue with is it spelled right and things like that. Is there enough characters in that column? Is it a different data type? That's some of the issues you can happen with joins, but most of the time joining on department ID is going to work, but watch out for differing strings and numbers and the join won't work that way. So make sure it's the same data type and that will help when you're joining the data. But here we are joining the departments on the employees table using the department ID. You can see where that's equal. You can actually do what's called an anti-join, where all these stuff is not, but that's for another day here. But this is a inner join. And there's different join types. Whenever you type out join, that just means it's an inner join. Only those columns that match are going to join. You could do what's called a left join. Let's say we did that here. We'd have all the columns in the employees table and those that match from, say, the departments table, if it was a left join facing the employees table. But if you did a right join, on the other hand, it'd be all the stuff, rows from the departments table, and then only those matching rows from the left join. And the way that kind of works is they're null values. There's nothing there in those other ones. And there's also things like a full outer join, but we won't go into that, and other types of joins, but those are the main ones: inner join, left join, and right join that you'll be using in SQL. Just know that a lot of times you may want to use a left join because let's say you just want all the employees, but you don't want to, if there's a null value, you don't always want it to go away. Maybe an employee doesn't have a department. Well, you're going to have some null values there and you want to keep those so you can find employees that don't have an assignee for department. Then you can use the employees table as a left join. That's your table you're keeping with everything in it from the employees. And on that right side, you have some null values if they don't have a department ID or anything like that. They'll show up as a blank. Null means blank, or sometimes it can be a 0, but most of the time it's just going to be null, which means blank. So that's what happens when you do a left join. You'll likely want to use left join a lot. If you're looking for speed and you know why you're cutting your data, you can use the join or inner join. Type that in, it does the exact same thing right there. Here the where is kind of where you're filtering. You're trying to get down to the data. So here we're filtering by the engineering department. So from the departments table, departments.department name, and that will get you where you need to go. I think one thing I would have done in this query, I would have probably changed it to employees to E, departments to D, to alias those, but just know this is set up. So there's actually something you could do to write this a little more efficiently, but the engineering department is what we're choosing from the departments table under the column department name equals engineering. I think sometimes you could also use like, or even I like is what I prefer. Especially I like doesn't take into account capitalization or other things there, but this gives you a good idea. You could also use in engineering and put parentheses around this, but just know this is, there's a couple ways you could do this. The equal sign the like or I like or N or equals engineering. So you have a couple options here with the where clause, but just know you can go about this different ways. Just make sure you're using the right syntax or it may not work. And then the group by is what we're grouping by. So we're going to get the employee's name and department name are all lined up together. And then you're going to aggregate the employee on the same row as a department name here. So if you just did employee's name, it would aggregate just the employee's name. If you just did the department name, it would aggregate the department name. But because you're aggregating employee name and department name together, they're aggregating together with everything that involves that employee in their department. So if an employee's in two departments, it's going to aggregate that employee each time for two departments. So watch out for data errors like that. It could cause some issues. Just be really smart about that as you're looking at your data and making sure that's behaving the way you intended, as it can result in some duplicates. The order by is a really great thing. Here we're doing descending. The default for order by is ascending, or the ASC, but the total salary descending, we're going by the highest salary, limit 10. This will give us the top 10 salary employees in the company, basically, with the department and employee name. So I think that's where you're at. So you're limiting it by 10. I will use a limit because it just makes a more structured query. So overall, this is a pretty good structured query. Sure, there's some tips here that you can do, but I think overall it's a pretty structured query with the inner join. And I think this gives you a good start with using your SQL. You're going to use select, from, join, where, group by, and order by mainly. Just remember, in your group by, in some SQL databases, you can actually use group by all. You don't have to list employee name, department name. You can actually just do group by all and do a couple summarizations. Whatever's in your select clause will then be the group by that you're using for your aggregation. So this is a great basic SQL query that gets you on the right path of finding data and some good practices and how that all works. And I think this gets you going as you start querying databases as a data analyst or data scientist, and will get you to that point where you need to be.